Welcome to Meteorology 101. Visit our website at meteorology101.com. There are two types of jet streams in both the north and south hemispheres: the polar front jet and the subtropical jet. There are three major types of tropopause leaves. The jet streams form between these leaves. The polar leaf. It is lower and therefore warmer than the other leaves and is generally located poleward of 60 degrees latitude. The mid-latitude leaf. Generally located between 30 degrees and 60 degrees latitude in both hemispheres. The tropical leaf. Generally located equatorward of 30 degrees latitude. It is higher and therefore colder than the other leaves. Causes of the jet streams. Jet streams are caused by primarily two reasons. First, large horizontal temperature contrast are associated with a large thermal wind vector. Second, the interaction between the Hadley and Farrell cells. Global circulation. Jet streams that form by large horizontal temperature contrast across the jet stream axis are at the tropopause because this is where contour gradient force is at a maximum. Above and below the tropopause, the slope of a constant pressure surface weakens. Jet stream dimensions. The typical dimensions of a jet stream include a length in thousands of kilometers and a depth of several kilometers. Jet stream structure. The wind speeds within the jet core are relatively uniform. Since there is not much difference in speed, there is normally very little wind shear. The jet axis is the axis of maximum wind speeds through the center of the jet core. Intermittent regions of the strongest wind speeds within the jet are called jet maxima. Isotach gradients. In the horizontal, the isotach gradients are stronger on the cold air side of the jet maximum. In the vertical, the isotach gradients are strongest above the jet stream. The isotach gradient relationship described applies directly to the polar front jet and to a lesser degree to the subtropical jet. Isotach gradient ranking from the strongest to the weakest are +C, -C, +N, -N, +S, -S. The primary cause of the polar front jet is the horizontal north-south temperature contrast. The polar front jet migrates with the season, and moves toward the equator in the winter and toward the poles in the summer. The continental polar air mass begins to move south out of its source region, causing the temperature contrast between air masses to move with it. Two main factors contribute to the formation of the subtropical jet. First, the convergence between the Hadley and Farrell cells. Second, horizontal temperature contrast, the interaction of warm moist subtropical air and cold dry polar air. The subtropical jet core is located between the mid-latitude and tropical tropopause leaves, approximately 150 to 200 millibars. Jet cirrus is commonly found on the warm side of the subtropical jet axis, often forming transverse bands. Shear and turbulence associated with the jet stream are directly related to the strength of the isotach gradient and stability. Shear is the difference between the wind speed or direction per unit distance. With the jet stream, shear is due mainly to the change in wind speed. Because of this, the greatest shear will be found where the isotach gradient is the strongest. These videos, although short, take hours to create. Please consider clicking the thumbs up and sharing this video.